The Middle East has long been celebrated as the cradle of civilization, but its role in shaping human history runs far deeper than just its cultural contributions. Imagine tracing the journey of our earliest ancestors, who walked out of Africa nearly 60,000 years ago, and realizing that their path ran straight through this very region. This ancient crossroads isn't just a meeting point for trade or ideas. It's also a genetic melting pot, where the story of humanity takes some fascinating twists. Now, here's something truly intriguing. Did you know that Middle Eastern populations have less Neanderthal DNA than almost any other non-African group? This genetic quirk sets them apart from Europeans and East Asians. It turns out that while most Eurasian populations mixed with Neanderthals after leaving Africa, Arabian ancestors seem to have avoided much of this interaction. Scientists suggest that this is partly because of a unique genetic heritage called basal Eurasian ancestry, which we'll dive into a bit later. But there's even more to the Middle East's role in our genetic journey. Over 125,000 years ago, when the Arabian Peninsula wasn't the arid desert we see today but a lush, green landscape, it became a haven for early humans. Archaeologists have discovered ancient tools and even fossils in places like Saudi Arabia and Oman, revealing that humans thrived in these fertile lands. Picture rivers winding through verdant valleys and an abundance of food, conditions that supported some of the earliest human settlements. Yet, for all its importance, uncovering the genetic secrets of the Middle East hasn't been easy. The region's harsh climate, with its intense heat and humidity, has made preserving ancient DNA a significant challenge. For decades, this meant that while other parts of the world revealed their genetic histories, the Middle East remained a blind spot. It wasn't until recent technological breakthroughs, like advanced genome sequencing and the recovery of ancient DNA from sites in Bahrain, that we finally began to piece together this vital puzzle. And the results? Absolutely groundbreaking. These discoveries have revealed how interconnected the Middle East was with ancient Anatolia, the Levant, and even Iran. They've also shown how unique the region's populations are, shaped by thousands of years of migration, adaptation, and survival in one of the most dynamic and challenging environments on Earth. The Middle East isn't just a crossroads of geography, it's a crossroads of humanity. Every artifact, every gene, every trace of ancient life discovered here is a clue to how we, as a species, moved, evolved, and adapted to the world around us. And as we uncover more of this region's DNA, we're finding that the story of the Middle East is, in many ways, the story of us all. Have you ever wondered how humanity spread across the globe, from small groups of early humans to vast, diverse civilizations? The Middle East holds the key to that story. For tens of thousands of years, this region served as the gateway between Africa, Europe, and Asia, a literal bridge where cultures, technologies, and genes converged. Let's rewind to around 60,000 years ago. As our ancestors ventured out of Africa, they were met with the Middle East's open landscapes, fertile oases, and mild climate, perfect conditions for sustaining life. This region became their first major stop. Imagine small bands of humans, carrying only the tools and knowledge they could muster, making their way through lush savannas, which have now been replaced by the Arabian desert. But migration didn't just flow out of Africa. Genetic evidence shows waves of people moving back into the Middle East from Europe, Anatolia, and even South Asia. Around 10,000 years ago, the advent of agriculture in the Fertile Crescent, the fertile land stretching from modern-day Iraq through Syria and into Turkey, triggered massive population movements. Farmers from Anatolia migrated southward, while local hunter-gatherer groups integrated with incoming populations. This mixing created a genetic mosaic, leaving traces of ancient Anatolians, Levantines, and Iranians in Middle Eastern DNA. Even more fascinating is the genetic evidence of trade and cultural exchange during the Bronze and Iron Ages. The bustling trade hubs of the Middle East, places like Mesopotamia, Bahrain, and the Levant, weren't just exchanging goods. They were also sharing genes. Traders, soldiers, and settlers brought their unique genetic signatures to the region, leaving a lasting imprint on local populations. And then there's the story of desertification. Roughly 6,000 years ago, the Arabian Peninsula transformed into the arid desert we know today. This change drastically altered migration patterns. Populations adapted by clustering around scarce water sources, and we see evidence of this in the genetic bottlenecks that occurred during this period. Imagine the resilience it took for ancient humans to survive in such harsh conditions. Their adaptability is written into the DNA of modern Middle Eastern populations. But perhaps the most surprising finding is the influence of ancient Iranian-related ancestry. Genetic studies reveal that this ancestry began spreading into the Middle East during the Bronze Age. It's believed to have contributed not just genes but also cultural and technological advancements, such as metallurgy and urbanization. This genetic influx coincided with the spread of Semitic languages, linking people across vast distances. What makes the Middle East truly extraordinary is its role as both a recipient and a giver. Populations here didn't just absorb influences, they also spread their unique genetic signatures far and wide. For instance, Middle Eastern DNA is found in parts of East Africa, South Asia, and even Europe, carried by ancient migrations and trade nets. When we think about the Middle East, we often picture towering deserts and ancient cities. But beneath that surface lies a rich genetic history, a tapestry woven from countless migrations, adaptations, and cultural exchanges. Every step taken by our ancestors, every interaction they had, has left its mark, creating a story that's not just about one region, but about the interconnectedness of all humanity. The ancient Middle East was home to some of the most remarkable civilizations in human history. But have you ever wondered how their rise and fall influenced the DNA of the region? Behind the towering ziggurats, bustling markets, and legendary stories lies a complex genetic history shaped by the interplay of empires, migrations, and cultural exchange. Let's begin with one of the oldest and most influential civilizations, Mesopotamia. Known as the Cradle of Civilization, Mesopotamia introduced groundbreaking innovations, writing, mathematics, and centralized governance. But its people were not isolated geniuses. DNA studies reveal that ancient Mesopotamians were a genetic melting pot. They carried ancestry from Anatolian farmers, Iranian pastoralists, and Levantine hunter-gatherers. The region's fertile plains attracted settlers from all directions, creating a diverse gene pool that reflected its position at the heart of ancient trade routes. Moving southeast, the Dilmun civilization flourished in what is now Bahrain. Archaeological evidence from this period aligns with genetic findings that connect ancient Bahrainis to populations from the Levant, Iran, and even the Indian subcontinent. Imagine the bustling ports of Dilmun, where traders exchanged goods and genes, alongside stories and ideas. The genetic signatures of these ancient maritime interactions still persist in the DNA of modern Bahrainis, a testament to the region's role as a hub of connectivity. But it wasn't just trade that shaped the genetic landscape. Conquests and empires left their marks as well. The Persian Empire, for instance, was one of the largest and most diverse empires of its time, stretching from the Balkans to the Indus Valley. This vast empire brought together people from different regions, facilitating not only cultural but also genetic mixing. Modern Iranians and their neighbors carry traces of this ancient Persian ancestry, highlighting the empire's enduring influence. One of the most intriguing genetic imprints in the Middle East comes from the Hellenistic period, following Alexander the Great's conquests. Alexander's campaigns stretched from Greece to Egypt and into modern-day Iraq, leaving a trail of cultural and genetic blending. For example, studies of ancient DNA from the Tylos period in Bahrain show genetic ties to populations from Greece and Anatolia, reflecting the Hellenistic influence in the Gulf region. This fusion of Greek and local cultures created a legacy that would shape the region for centuries. And then there's the Roman Empire. Though its direct influence in the Middle East was shorter-lived than in Europe, its impact on trade and migration left genetic traces. Roman roads, ports, and trade routes connected the Middle East to the Mediterranean, facilitating the movement of people and their genes across vast distances. But what about the Arabian Peninsula itself? Long before Islam united the region, nomadic tribes crisscrossed its deserts, their movements dictated by the search for water and pasture. Genetic evidence shows that these tribes maintained strong ties with populations in the Levant and East Africa. The Arabian Peninsula's harsh environment acted as both a barrier and a bridge, preserving unique genetic traits while facilitating selective exchanges with neighboring regions. The fascinating thing about ancient civilizations is how their genetic legacies continue to shape modern populations. DNA doesn't lie. It carries the imprints of every conquest, every trade route, and every migration. Today, when you look at the genetic makeup of Middle Eastern populations, you can see the echoes of Mesopotamians, Persians, Greeks, and many others. It's like a living history book, written in the language of genes. So the next time you think about the ancient Middle East, remember, it wasn't just a stage for great civilizations. It was a crossroads where human history was written, not just in stone tablets and monuments, but in the very DNA of its people. It's hard to overstate the role of agriculture in shaping the Middle East, not just its civilizations but also the DNA of its people. Imagine the moment when early humans transitioned from hunting and gathering to farming and settled life. This pivotal shift didn't just revolutionize society. It left an indelible mark on our genetics. Agriculture first emerged around 12,000 years ago in the Fertile Crescent, an arc of lush land stretching from modern-day Iraq through Syria and into Turkey. The introduction of farming meant humans could stay in one place, leading to larger populations, permanent settlements, and, eventually, the rise of cities. But with this sedentary lifestyle came new genetic pressures. For starters, farming populations experienced significant changes in diet. Early farmers relied heavily on grains like wheat and barley, which were rich in carbohydrates but lacked the variety of nutrients found in a hunter-gatherer diet. Over time, genetic adaptations emerged to compensate for this dietary shift. For example, some genetic variants related to lactose tolerance began appearing in Middle Eastern populations. This allowed early farmers to digest milk from domesticated animals, giving them access to an additional source of nutrition. But the story doesn't end there. Farming also led to changes in how humans interacted with their environment. As settlements grew, so did exposure to new diseases. Larger populations meant closer living quarters and unsanitary conditions, creating the perfect breeding ground for pathogens. Genetic evidence suggests that certain immune system adaptations became more common during this period, helping populations resist diseases like malaria and tuberculosis. One of the most fascinating examples of this is the G6PD Mediterranean mutation, which is found at high frequencies in the Middle East. This genetic trait provides protection against malaria, a disease that likely became more prevalent as agriculture expanded into new areas with standing water for irrigation. However, this mutation is a double-edged sword. It also causes G6PD deficiency, which can lead to severe anemia when exposed to certain foods or infections. Then there's the role of climate. Around 6,000 years ago, the Arabian Peninsula underwent a dramatic transformation. The lush, green landscapes that had once supported early humans turned into the arid deserts we see today. This period, known as the Dark Millennium, coincided with a significant bottleneck in the genetic diversity of Arabian populations. As resources became scarcer, populations shrank, and migration patterns shifted. Yet, even in the face of these challenges, people adapted. Genetic studies show that Arabian populations carry unique adaptations to their harsh environment. Traits linked to efficient water retention and heat tolerance are more common in this region, highlighting the incredible resilience of early humans. Climate also influenced migration patterns, bringing new genetic influences into the Middle East. As deserts expanded, populations from the Levant, Anatolia, and even East Africa moved into more hospitable areas. This influx of diverse groups added new layers to the genetic mosaic of the region. For example, the genetic signatures of Anatolian farmers and Levantine herders are still detectable in Middle Eastern populations today, a legacy of these ancient migrations. The interplay between agriculture, climate, and genetics didn't just shape ancient populations. It continues to affect us today. For instance, some of the genetic adaptations that helped our ancestors survive, such as those related to diet and immunity, are now linked to modern health challenges. Traits that were advantageous in the past, like the ability to store fat efficiently, may contribute to the prevalence of metabolic disorders like diabetes in contemporary Middle Eastern populations. What makes this story so compelling is its dual nature. It's a tale of survival against the odds, of humans adapting to sweeping changes in their environment. But it's also a reminder of our shared history, written in the genes we carry today. The transition to farming and the dramatic climate shifts of the past weren't just historical events, they were transformative moments that shaped who we are, both as individuals and as a species. And in the DNA of Middle Eastern populations, we can see the traces of those profound changes, connecting us to a time when survival depended on innovation, adaptation, and resilience. The story of Middle Eastern DNA would be incomplete without understanding the profound influence of migration and trade. The region has always been a crossroads, linking Africa, Asia, and Europe. Its strategic location and rich resources made it a hub for commerce, conquest, and cultural exchange. But what does this mean for the genetic fabric of the people who have lived here? Let's start with the Bronze Age, around 5,000 years ago. This period saw the emergence of powerful civilizations like Mesopotamia, ancient Egypt, and the Indus Valley. These societies weren't isolated. They traded goods, ideas, and people. Ancient DNA reveals genetic signatures from the Levant, Iran, and even South Asia in Bronze Age populations, showing how trade routes brought not just goods but also new lineages to the region. Take the Dilmun civilization of Bahrain, for example. Historical records and archaeological findings describe Dilmun as a thriving trade hub connecting Mesopotamia and the Indus Valley. Recent genetic studies of ancient Bahraini remains show a mixture of Levantine, Iranian, and South Asian ancestry. This diverse genetic makeup reflects the movement of merchants, sailors, and settlers who passed through Dilmun's bustling ports. But trade wasn't the only driver of migration. Conquests and political shifts brought waves of new people into the Middle East. One striking example is the spread of Iranian-related ancestry during the Bronze and Iron Ages. Around this time, populations carrying steppe and Iranian ancestry moved into the region, introducing new genetic components. These movements coincided with the rise of empires like the Achaemenid Persians, whose influence stretched from Egypt to India. The Hellenistic period, following the conquests of Alexander the Great, brought further genetic mingling. The spread of Greek culture and people throughout the Middle East left a subtle but detectable mark on the region's DNA. For instance, some genetic studies of ancient Middle Eastern populations have identified small traces of European ancestry from this era, particularly in places like Lebanon and Syria. Religion also played a key role in shaping migration patterns. The advent of Islam in the 7th century CE led to an unprecedented wave of movement. Arab tribes from the Arabian Peninsula expanded across the Middle East, North Africa, and beyond. This Islamic expansion wasn't just a military or cultural phenomenon. It was a demographic one. Genetic studies reveal the spread of Arabian DNA into regions like North Africa and the Levant, where it blended with local populations. But migration wasn't always voluntary. The Middle East was a major center for the transcontinental slave trade, which brought people from sub-Saharan Africa, Central Asia, and Europe into the region. These forced migrations have left a genetic legacy that's still visible today. For example, some populations in the Arabian Peninsula show significant African ancestry, likely a result of this dark chapter in history. Trade routes like the Silk Road and the incense route further deepened the region's genetic diversity. These ancient highways connected the Middle East to China, India, and even Europe, facilitating the exchange of not just spices and silk but also ideas and people. For instance, genetic studies have found traces of South Asian and East Asian ancestry in some Middle Eastern populations, a testament to the reach of these trade networks. Yet, amidst this influx of diversity, some Middle Eastern populations maintain distinct genetic identities. The Bedouin tribes of Arabia, for example, show unique genetic markers that set them apart from neighboring groups. These markers suggest that while the Bedouins may have traded and interacted with others, they maintained a relatively closed gene pool, preserving their cultural and genetic heritage over millennia. One fascinating aspect of this genetic mosaic is how it reflects historical events. For example, the Y chromosome haplogroup J1, which is common in the Middle East, has been linked to the spread of Semitic languages. This lineage likely expanded during the Bronze Age, carried by migrating groups who brought both their genes and their languages to new regions. In modern times, the Middle East remains a region of movement and exchange. Oil wealth, global trade, and political instability have all contributed to new waves of migration. Today's Middle Eastern populations are a living testament to thousands of years of movement, adaptation, and blending. What makes this story so remarkable is the sheer scale of interconnectedness. In the DNA of a single individual from the Middle East, you might find traces of African, European, South Asian, and even East Asian ancestry. This diversity isn't just a scientific curiosity. It's a reminder of the deep connections that bind humanity together. The Middle East, with its rich history of migration and trade, stands as a testament to the resilience and adaptability of its people. It's a region that has always been shaped by the flow of goods, ideas, and genes, a crossroads of the ancient and modern worlds. And through the lens of DNA, we can see the echoes of these journeys, reminding us of the shared heritage that connects us all. In recent years, breakthroughs in DNA technology have given us tools to decode history in ways that were once unimaginable. For the Middle East, a region so rich in history yet often misunderstood, these discoveries are reshaping how we understand identity, ancestry, and connection. One of the most striking revelations is the sheer genetic diversity of the region. Despite sharing cultural and linguistic commonalities, Middle Eastern populations show profound genetic variation. This isn't surprising given the region's role as a bridge between continents, but what's remarkable is how specific genetic markers reveal the stories of ancient migrations, adaptations, and intermingling. Take the Arabian Peninsula, for example. For decades, researchers believed it was merely a transit point for early humans moving out of Africa. But recent studies tell a different story. The people of Arabia aren't just descendants of passing migrants. They include genetic lineages that may have survived in isolation through the harsh aridification of the region. Some Arabian populations have a unique basal Eurasian ancestry, an ancient lineage distinct from the genetic heritage of most other non-Africans. This discovery challenges earlier assumptions, placing Arabia not as a periphery but as a central player in human history. Another fascinating finding involves the genetic ties between the Levant and Europe. For years, historians documented cultural exchanges between these regions during the Crusades and the Roman Empire. Now, DNA evidence confirms that genetic intermingling also occurred. Ancient Lebanese DNA, for instance, shows traces of European ancestry, likely introduced during periods of sustained contact with Mediterranean populations. Similarly, modern DNA studies have revealed unexpected connections between the Middle East and South Asia. These links stem from ancient trade routes, like the Silk Road and the Indian Ocean Trade Network, which facilitated the movement of goods, ideas, and people. Genetic markers found in the Gulf populations today point to historical interactions with South Asia, particularly during the thriving trade periods of the Dilmun and Sasanian empires. Perhaps one of the most surprising discoveries is the low levels of Neanderthal ancestry in Middle Eastern populations compared to Europeans and Asians. Scientists attribute this to the high proportion of basal Eurasian ancestry in the Middle East, which diluted the Neanderthal genetic contribution. This finding not only sets the region apart but also raises questions about how early human populations interacted and adapted as they spread across the globe. Modern research has also illuminated the enduring genetic impact of historical events like the Arab expansion during the 7th century CE. As Islam spread across the Middle East and North Africa, Arab tribes migrated and settled far beyond their original homelands. This expansion introduced Arabian genetic markers to places as far-flung as Spain and Sudan. Yet, the genetic influence wasn't one-sided. As Arab tribes mingled with local populations, they absorbed new genetic elements, creating a mosaic of shared ancestry that spans continents. One of the most transformative aspects of modern genetic research is its potential to redefine identity. For centuries, national and cultural identities in the Middle East have been shaped by history, religion, and tradition. But DNA tells a story that transcends borders and unites people. For instance, genetic studies show that Iraqis, Syrians, and Lebanese have significant overlaps in ancestry, highlighting a shared heritage despite modern political divisions. And it's not just the ancient past that genetic research is uncovering. Scientists are also studying how the region's recent history, marked by colonization, war, and migration, has shaped its genetic landscape. For example, the genetic diversity in Gulf populations today reflects a blend of Arabian, African, and South Asian lineages, a testament to the region's status as a historical trade hub and its modern economic connections. What's truly exciting is how these discoveries are challenging stereotypes. The Middle East has often been portrayed as culturally homogeneous, yet its genetic diversity tells a different story. It's a region of contrasts, where the deep ancestry of ancient hunter-gatherers meets the recent influences of global migration. These findings also have implications beyond history. By identifying genetic variants unique to the Middle East, scientists are making strides in understanding diseases that disproportionately affect the region's populations. From genetic disorders like G6PD deficiency to traits linked to metabolic diseases, this research could pave the way for more targeted medical treatments. Ultimately, Modern DNA research is not just rewriting the history of the Middle East, it's reshaping its future. It reminds us that identity is not static but dynamic, shaped by countless generations of movement, adaptation, and connection. It shows that the story of the Middle East isn't confined to the borders drawn on maps. It's written in the genes of its people, a living testament to the region's resilience and its role as a cradle of human civilization. As we continue to uncover the secrets hidden in DNA, one thing becomes clear. The Middle East story is far from over. It's a story of interconnectedness, of shared humanity, and of a legacy that continues to shape the world today. The Middle East, often referred to as the cradle of civilization, holds a unique place in the story of humanity. But its significance extends beyond the historical and cultural. It's also a genetic treasure trove. For scientists, the Middle East offers a window into the complex web of human ancestry, adaptation, and migration. Why is the region so valuable for genetic research? It all starts with geography. Positioned at the crossroads of Africa, Europe, and Asia, the Middle East has been a natural meeting point for human populations throughout history. This intersection of trade routes, migrations, and conquests has created a genetic melting pot unlike any other region in the world. The Arabian Peninsula, for example, was one of the first stops for early humans leaving Africa. Fossil evidence shows that modern humans lived in the region as early as 125,000 years ago, and genetic studies confirm that Arabian populations carry traces of some of the earliest human migrations. But unlike other parts of the world, Arabia's ancient population didn't mix significantly with Neanderthals, resulting in a unique genetic profile. The Levant, too, offers unparalleled insights. As the birthplace of agriculture, it was home to the Neolithic Revolution, arguably the single most transformative event in human history. DNA studies reveal that early farmers from the Levant spread their knowledge of agriculture, along with their genes, across Europe and parts of Asia. This makes the region pivotal to understanding how ancient human societies transitioned from hunter-gatherers to settled communities. What makes the Middle East even more fascinating is its history of adaptation. The region's shifting climate has forced its inhabitants to continuously evolve and adapt. Around 6,000 years ago, the Green Arabia period ended, and the Arabian Peninsula transformed into a desert. Populations that once thrived in lush environments had to adapt to arid conditions, leaving genetic footprints that persist today. For instance, genes associated with heat tolerance and water retention are more prevalent in Middle Eastern populations than in most others. But the story doesn't end with adaptation to the environment. The Middle East has also been shaped by its role as a hub of global trade and empire building. From the ancient Silk Road to the bustling ports of the Gulf, the region has always been a bridge between cultures. Genetic studies have uncovered evidence of this connectivity, revealing how Middle Eastern populations intermingled with traders, settlers, and conquerors from South Asia, East Africa, and the Mediterranean. One example of this interconnectedness is the high prevalence of African ancestry in certain Arabian populations, a legacy of both ancient migrations and the Indian Ocean slave trade. Similarly, South Asian genetic markers in Gulf populations point to centuries of trade and cultural exchange with the Indian subcontinent. Yet, despite its genetic richness, the Middle East has been historically underrepresented in global genomic studies. Projects like the Human Genome Project and the 1000 Genomes Project included only a handful of Middle Eastern populations, leaving a gap in our understanding of human diversity. Thankfully, this is beginning to change. Recent advancements in DNA sequencing technology have made it possible to analyze ancient and modern Middle Eastern genomes with unprecedented precision. Studies have uncovered millions of genetic variants unique to the region, many of which are linked to traits like lactose tolerance, metabolic efficiency, and resistance to certain diseases. One of the most fascinating findings involves the G6PD gene. This gene mutation, which is common in Middle Eastern populations, offers protection against malaria but can also lead to a condition called G6PD deficiency. By studying how this mutation spread and persisted in the region, scientists are learning more about how humans adapt to disease pressures over time. The Middle East is also shedding light on the spread of languages and cultures. Genetic research has shown that the spread of Semitic languages, for instance, was closely tied to population movements from the Levant into Arabia and East Africa. This provides a powerful example of how genetic data can complement historical and linguistic evidence to tell a more complete story. What's truly exciting is how this research is influencing modern medicine. The genetic insights gleaned from Middle Eastern populations are helping scientists develop targeted treatments for diseases that disproportionately affect the region, such as diabetes and cardiovascular conditions. They are also providing new tools for studying rare genetic disorders, many of which are more common in populations with a history of consanguinity, like those in the Middle East. But beyond the science, the Middle East genetic story is also a deeply human one. It reminds us that our differences are often the result of adaptation to unique challenges, while our similarities reflect the shared experiences of our ancestors. The genes that helped ancient Middle Easterners survive in a harsh desert environment or fight off diseases like malaria are the same genes that continue to shape the health and resilience of their descendants today. In many ways, the Middle East is a microcosm of the human story, rich, complex, and interconnected. Its genetic history is a testament to the resilience and adaptability of humanity, and it offers lessons that resonate far beyond its borders. As scientists continue to delve into the region's genetic mysteries, one thing is certain: the Middle East will remain a focal point for understanding not only where we come from but also where we're headed as a species. The DNA of the Middle East doesn't just unlock secrets of the past, it also serves as a blueprint for the future of genetics and medicine. As we dig deeper into the genomes of the region, we're uncovering critical insights that could transform how we approach health, disease, and even our understanding of human potential. One of the most immediate benefits lies in medicine. Middle Eastern populations have unique genetic markers that offer clues about susceptibility to certain diseases. For example, conditions like type 2 diabetes and cardiovascular disease are particularly prevalent in the region, and genetic research has shown that part of the reason lies in adaptations from thousands of years ago. Traits that once helped people survive harsh environments or food scarcity now make them more prone to metabolic disorders in modern, sedentary lifestyles. But understanding these genetic traits isn't just about diagnosing disease, it's about preventing it. By studying Middle Eastern DNA, researchers are developing tools to predict who is at risk for these conditions long before symptoms appear. Personalized medicine is becoming a reality, with treatments tailored to individual genetic profiles. Imagine a future where your doctor can prescribe a diet, exercise plan, or medication based on the genetic legacy of your ancestors. Another groundbreaking area is rare genetic disorders. In the Middle East, consanguineous marriages between close relatives, have historically been common, which has led to a higher prevalence of inherited conditions. While this presents challenges, it also creates opportunities. The concentration of these genetic traits makes it easier for researchers to identify the mutations responsible for certain diseases. Already, studies in the region have led to the discovery of new genes linked to conditions like familial hypercholesterol, a disorder that causes high cholesterol from a young age. These discoveries don't just benefit the Middle East, they have global implications. Understanding how these genes work can lead to breakthroughs in treatments for people all over the world. The Middle East is also playing a key role in the fight against emerging health threats. As the global climate changes, so does the spread of diseases. For example, malaria, which has historically been a major health concern in parts of the region, is now re-emerging in areas where it had once been eradicated. By studying the genetic adaptations that helped ancient Middle Easterners survive malaria, scientists are finding new ways to combat the disease today. But the potential of Middle Eastern DNA goes beyond medicine. It's also reshaping our understanding of human evolution and migration. For decades, researchers assumed that humanity's story was largely linear, a series of migrations out of Africa that gradually spread across the globe. But the genetic diversity of the Middle East is revealing a more complex picture. For instance, the discovery of ghost populations in Arabian genomes, groups of ancient humans that left no fossil record but still contributed to modern DNA, challenges the traditional narrative. These findings are forcing scientists to rethink how different human groups interacted and interbred over millennia. The region's genetic story is also helping to resolve debates about language and culture. By tracing the movement of genes, researchers can map the spread of Semitic languages, showing how people from the Levant carried their culture into Arabia and beyond. This kind of interdisciplinary research, combining genetics, archaeology, and linguistics, is opening up entirely new ways of understanding history. Looking ahead, the Middle East is poised to play a leading role in the global genomics revolution. Countries in the region are investing heavily in genetic research, establishing national biobanks and sequencing initiatives. The UAE's Genome Program, for example, aims to sequence the DNA of every Emirati citizen, creating one of the most comprehensive genomic databases in the world. These initiatives aren't just about advancing science, they're about empowering local populations to take control of their health and their future. But with great power comes great responsibility. The growing focus on genetics raises important ethical questions. Who owns genetic data? How should it be used? And how do we ensure that the benefits of genetic research are shared equitably? These are questions that researchers, governments, and communities will need to answer together. What's clear, however, is that the DNA of the Middle East is more than just a record of the past, it's a guide to the future. It reminds us of our shared humanity and our capacity for adaptation and resilience. And as we continue to unlock its secrets, it promises to revolutionize not just how we understand ourselves, but how we shape the world to come. The journey through Middle Eastern DNA is nothing short of extraordinary. From ancient migrations and cultural revolutions to the very fabric of modern genetics, the region's DNA tells a story of resilience, adaptation, and interconnectedness. It is a living archive, capturing the rise and fall of civilizations, the impact of climatic shifts, and the enduring spirit of human innovation. But this story isn't just a window into the past, it's a bridge to the future. As we've seen, the genetic discoveries emerging from the Middle East hold immense promise for medicine, archaeology, and our understanding of human evolution. They remind us that every gene carries not only the weight of history but also the potential for groundbreaking solutions to today's challenges. The Middle East's contributions to the global genetic tapestry highlight the beauty of diversity. They show us that while our histories may differ, our shared genetic roots bind us together. In an era when divisions seem to dominate, the lessons of DNA, of migration, mixing, and shared ancestry remind us of our shared humanity. So, the next time you hear about ancient DNA studies or groundbreaking medical advancements, remember, the story of the Middle East's DNA isn't just their story, it's all of ours. It's a testament to how far we've come and a guide to where we're headed. It's a narrative of hope, resilience, and discovery that will continue to unfold for generations to come. What other mysteries might the genes of the Middle East reveal? What other connections, long hidden, might come to light? As science advances, one thing is certain, the story of Middle Eastern DNA is far from over. It's a chapter in the grand narrative of humanity, and its next pages are waiting to be written.